Have you ever stared at an add math problem and your brain just starts to like freeze up out of nowhere? Like, you know the topic related to the question, you know that there's some method you're supposed to use, but at the end of the day, you just don't know how you're supposed to link everything together. I've been there. And trust me, I know great students who run into the same problem. Hi, my name is John. I'm a second year undergraduate studying computer science, and I have been a tutor for the past 2 years or so. And the one thing I notice while tutoring math to many of my students is that the best students often don't rush into solving the problem, but rather take the time to first organize how they think so that they can approach the problem more effectively. So that's why today I thought it'd be kind of cool if I could show you guys a simple technique that I teach all my students, and it's called flex. It's a very easy way to break down the problem into multiple manageable steps so that you can solve your problems more easily and more effectively. So let's walk through a sample problem together to see how you would actually flex in an actual problem. And by the way, this is a differentiation question. If you're not familiar, it's completely fine. The mental models that I'm going to teach you today apply to pretty much everything. Okay, so let's start off with reading the question. It says here that it's given that y is equal to mx squared plus x over 2 plus n, where m and n are non-zero constants. It's also given that 3 of the second derivative is equal to dy dx squared minus y for all values of x. Find the values of m and n. Very non-trivial question. It's not really asking you for the derivative. Again, if you don't know what that means, it's fine. But the first thing that I would do in this situation is to first find any details here and extract all the information that you can. Okay, that's the F in flex. Okay, so I would take out my handy highlighter. I'm just gonna highlight this portion because it looks important, and M and N, right? Because those are the two things that I'm looking for. Then the second process, okay, the second part of flex is to look around. Okay, you want to explore. Okay, this is not the same thing as just going to the final answer. It's more like you're trying to find if there's any extra piece of evidence that you can gather from, switching expressions, applying a rule that you know. Okay, so for example here, I noticed that I could technically find the derivative of the first equation, this one, right? I can just use my power rule to easily find out that dy over dx is equal to 2mx plus half. Same thing with the second derivative. Again, another step of exploration. I realized that, hey, if I just apply the power rule to this again, I could technically just find the second derivative. So I'm just going to do that. Dy dx squared, this is equal to 2m. So now that we have this exploration step finished, what else can we do? The third step is to link everything together. Okay, it's to establish connections. That's the E in flex. Okay, so what do I mean by that? Well, given this base set of equations, right? What can I do with this? How can I establish a connection with what I already know? Well, I realized that now, hey, I have an expression for this dy dx, and I have an expression for this dy dx as well, the second derivative. So what I can do is just substitute everything inside the second equation. I mean, that's the one connection that I can find, right? So might as well try it. Let's just try. We have 3 of 2m is equal to 2mx plus half square minus y. Okay, not gonna bore you with the details, but like expanding this out, you would get something like 6m is equal to 2mx squared plus 2mx half plus half square minus y. This process would continue, obviously. Again, the point of this video is not to explain to you how to solve this problem, but rather like the idea, the mental models you're supposed to have. I'm just going to quickly run through the rest of the solution. If you want to just pause the video and see this, then go ahead. So yeah, I mean, that's pretty much it. The hardest part is really just finding that initial connection, realizing that you have to substitute dy dx and the second derivative, and then after that, going through this process of expanding and finding equalities to find finally the values of m and n. That's not all though. You don't stop here. The last part of flexing is x, okay? To examine all the process, the flows, the calculations that you've done, and making sure that everything is correct. So I mean, I'll just briefly run through my calculations here. You have this looks good, this looks good, this looks good, this looks good, and then we're comparing the coefficients here, which is fine, and running through these. Yep, looks great. So yeah, I mean, that's it. I think the most important takeaway from this video is probably this idea that you should be breaking things down more often. If you're immediately jumping into solving the problem without really understanding all the facts that are given to you, it's obviously going to be way harder for you to reach the final solution. Right, so again, just to recap what flex really means. F means to find all the details, L means to look around, explore, E means to establish those connections, and lastly, X means to really examine your work, right? Validate everything, make sure everything is ready to be submitted. Right, thanks so much for watching. I'll see you in the next one for more math video tips. Bye.